Good afternoon, all. Am I audible to you? That's great. Now, today we'll continue the discussion on smoothing, and then we'll go for some other parameters, and later on we will move to some other filters and its uh, their applications. Okay. So let us quickly go through. So what we concluded here that if my operations are like linear operations between the window and the selected neighborhood, then it is a linear filter. That means what you need is that you can have operation like multiplication, addition kind of operations, and they are linear operations that you know very well, and that's why they were the linear filters. And we use this standard box filter, or we can say average filter, standard average, or box filter, whatever you call it. If it is 3 cross 3 size, then it is 1 by 9 and all. If it is 5 cross 5 size, then it is 1 by 25 and all will be 1. Right? So that will be standard average filter or box filter, and weighted average will be like you are giving particular weight to particular pixel, and the summation of all those weights will be divided, so that you can consider it like a it is like weighted average thing. So this is the same thing that we have just discussed in terms of equations where weights are summed up here. So these are all the cases of smoothing we discussed. Like what is the application that you want to remove the clutter from small clutter from the image. Like you are having small stars here. If you are having a floor image, you want to detect a floor. Suppose you are having automated robot, right? So it has to navigate in the floor. So what can happen that you want to detect the floor for that reason. So what you want to do that first of all you will detect the floor, then you will decide the direction. But for detecting floor, the actual area of the floor, if you want to detect, you have to remove that some shadow of the light over there, or some unwanted clutter is there, that you can remove to find out actual area of floor. So at that time also this can be useful. Right, what was the conclusion here? That if my object size is smaller than my mask size, then it is totally removed. Okay, so I think this all things we have already discussed. So now we are going for the non-linear filter. What is that? That is non-linear operation we are going to perform, like finding maximum or minimum from the neighborhood. So what we will need here, that in my image, so now it is very simple case, right? This is my image, right? I'm selecting my pixel, right? I want to find out. Okay, okay, is it visible now? Okay, that's great. So okay, so now we are going for we are going. So now this is my image, and then I want to go for modification of this pixel, and that pixel is reflected somewhere here in my output image, right? This is my output image. So I want to find out what will be that pixel value in the output image after applying some non-linear filter. How my non-linear filter looks like. So I will select that pixel. I will select its neighborhood. That neighborhood size can be 3 cross 3, 5 cross 5, 7 cross 7 of your choice. That can be anything. Now I have a size of a neighborhood that I have decided whatever it is. After that, I want to have an operation that is to be performed, and that operation can be minimum or maximum kind of thing. Like not it should not be like multiplication, and it should not be the linear operation. It should be non-linear operation, and that's why it is a non-linear filter, right? So if you are going for non-linear operation like finding minimum, finding maximum, okay. So so what is the meaning of that? I will take all the elements in the neighborhood, and I will find out minimum element out of this, and that will be my mean filter. Okay, suppose I am going for max filter, then I will take all the elements of my neighborhood, all 9 elements, and out of that 9 elements, whatever the maximum element value will be, that will be replaced at the center location in the output in the output image. Okay, one more filter that we are having is median filter. What is that median filter? So in that, what will happen that I will take all 9 elements and I will find out median of that, and that median is replaced with at the center location. Right. So let us take that example and let us understand it in better way. Suppose there is 0, then 1, then 3, then 4. Let us take some even better example. So z. Okay, let us take that and then we will modify the example. 1, 3, 2, 4, 2, 1, 0, and 3. Suppose this is my neighborhood selected, then can you tell me what will be the value of the center pixel at this location in the output image? What will be the value of output image at this location if I am applying mean filter? What will be the value at this location? Mean filter, MIN filter, that is minimum of this 9 elements should be replaced at the center location in the output. So what should be the value? Quickly. Yes, it should be 0. It should be Anmol. Why it should be 1? Minimum is 0, na? Yes, it should be okay. That should be 0. Okay, if I am using max, then so what actually you did? You actually wrote it in order. You wrote like this is 0, this is 0, 1 0, and then second 0. Then 1 pixel is having value 1. Then 1 pixel is having value 1. Right? Then 2 pixels are having value 2. So 2 pixels are having value 2. I am arranging these values in ascending order. Right, and then 2 pixels are having value 3, so 2 pixels are having value 3 here, and then fourth last pixel is having value 4, so 1 2 3 4 5 6 7 8 9. So these are 9 elements I have arranged in the ascending order, and for minimum I took the first element. Can I say like that? If I did so, now can you tell me for the max what will be the value here? What will be the value here? Yes, it should be for the max filter, it will be 4. And can you tell me for median what it will be? If I use a median filter, so at this location in the output, what will be the value? Median. For max, it is 4. For mean, it is 0. For median, how to find median? Yes, it is the center value of all this 9, right? So it is 2. So this is one element from the left, one element from. So if I'm having 9 elements, then fifth element is my median. So this is 1, 2, 3, 4, 5, 6, 5. So this is my median because it is my centered element in my ascending order list, right? um, 1 2 3 4 5 6 7 8 9. Okay, so yes, it is the fifth element, and that is this 2 is my median. Yes, it is median. Okay, so this, can I say, actually I need order of my elements to have this type of filtering process. That's why it is known as order statistic filters. These are using order of the element, right? Ascending order, descending order, you have to arrange like that, right? So that's why these are known as order statistics filter. Also, they are non-linear filter as well as they are order statistic filters. Okay. Now, one more thing that I would like to ask, that suppose I am having a cluster of zeros or cluster of ones, right? Suppose I am having a cluster of zeros. So how it will look like? Suppose I am having just a second. So let us have this type of cluster. So I'm changing the values. Okay. So what will be the order now that I have three zeros? I have three zeros, only one one, two twos, and two threes, and one four. What will be the median now? What will be the median now? What is the current median in this value? What will be the output if median is applied? with this values, what I changed, I created a cluster of zeros, a group of zeros. Can you tell me what is the value here? What is the new value now of median? If I am having a cluster, are you getting my question? What I did, I've changed the values here. I've created the group of zeros here. And then I want to apply median filter. So I'm going to arrange this value into ascending order. Right? What should be the value now of the median? Quickly. If you are not getting, you can tell me. I can repeat. Are you clear with this? Are you getting this? If not, then answer no. Yes, median is going to be 2. Median is 2, right? Median is 2. So, okay. So, can you tell me what should be the, if it is how large cluster I can eliminate? Here I eliminated the cluster of all zeros. There was a group of zeros and I eliminated it. So, what is the size of the cluster that I eliminate if I'm using? Suppose instead of 3 zeros, if it would have been 5 zeros, would it be possible to eliminate that cluster? Suppose in my image I am having 5 zeros. Here also there is a 0. Here also there is a 0. Suppose 5 zeros are there, then will it be possible to eliminate that zeros? Five zeros in my neighborhood. See, you are wasting the time. If you are clear, it is not a difficult question, right? If you are not interested, we can skip and we can go to the next interesting topic, right? Last time I am asking, if not clear, you can answer no. I am not going to repeat this every time. Okay. So, what is the case? If I am having 5 zeros, then will it be possible to eliminate the 0? What will be the median value now? If this is the scenario, what is median value? Yes, median value is 0, right? Median value is 0. Okay. So, what is our conclusion here? That what is the maximum size of cluster that I can eliminate? What is the maximum size of cluster that I can eliminate? How many zeros are together that I can eliminate using median? Yes, 4. How that 4 comes? That's absolutely right. How that 4 comes? Okay, suppose it is 5 cross 5, then also it will be, suppose my window size is 3 cross 3. My window size is 3 cross 3, right? Suppose it is 5 cross 5, then also that will be 4 only, that I will be able to eliminate only 4 zeros at that time. Suppose I have 5 cross 5, then median will it be n by 2? 3 by 2? N minus 1 by 2? Think of, you are correct that it relates with the window size. But what is the relation? N is what? N is number of element if you are considering. Then true. But n, if you are considering n cross n, if I am considering this n cross n, then yes, I understood what was your point. Your point was, I think, 9 elements. In that way, you considered n. But we should consider our window as n cross n. Then, yes, it will be n into n minus 1 by 2. Rather, I should say that it is cluster smaller than the size of n square by 2. Can I say that like that? It is not exactly that one, but all the clusters smaller than n square by 2 are eliminated. Okay, everyone is clear with this? Okay, that's good. So that is what we are having here. Okay, so what is that light? So what is the meaning of that? That light area is what? Or dark area? What is, if I am having cluster of zeros, what is the meaning of that? Cluster of zeros, what is the meaning of that? It is a dark region. Same way, if I am having the values here, all are 255 values here, so I can also eliminate them too, right? I can eliminate dark region or bright region bright region with the cluster value of the cluster size n square by 2. If it is zeros, then also it can be eliminated. If it is on the right hand side, then also it is eliminated because we are taking center value, right? So dark region or the light region, they are if they are smaller than the size n square by 2, then they are eliminated by median filter of n cross n size. That is a general statement and useful statement, right? Any doubt in this statement? In case, please ask. Okay, then we will understand the application of this filter. Okay. Now observe, are you clear with this up to this? Any doubt? In case, please ask. Mean filter, max filter, right? Mean filter is also known as 0th percentile filter. Why it is known as 0th percentile? Because first element you are choosing, right? Max filter is also known as 100th percentile filter, right? Because you are choosing the maximum element there. So that are the other names of these filters that you can find out in your textbook. Okay, so order statistic filters are based on ranking, ordering of the pixels, and they are useful for certain tasks. What are those tasks? Now we are having our image, right? It has some scene, right? Some this type of image we are having, right? Now what happens that suppose noise occurs. Which kind of noise occurs? Suppose salt and pepper kind of noise occurs. What is that? Salt and pepper, as the name suggests. As in paper, what happens that you will feel like this paper is sprinkled over image. Somewhere sudden occurrence of black dot will be there. You will have this type of black dot. Now you feel that image is noisy, right? It is noisy image because this is paper noise. What is that? This type of noise occurs in your image, then it is a paper noise. That means it is having um, that sudden occurrence of zeros, right? Then we are having salt noise. What is salt? How salt looks like? It is a white. The white dot will occur in your image. Somewhere suddenly white dots will occur, and both together, if they are occurring, sudden occurrence of white and sudden occurrence of black dots are there, then it is salt and pepper noise. Okay. Now, what is the meaning of sudden occurrence of black dot? Which intensity suddenly occurs? Suppose I select this region of my neighborhood. Here, sudden occurrence of uh, paper noise is there, right? That means otherwise my area is gray, but suddenly which intensity takes place? Which intensity suddenly occurs? Occurs zero, right? Same way in salt noise, which intensity will suddenly occur? In paper noise, zero. In salt noise, 255. True, it will be 255. Okay. Now suppose let us take that scenario here. Okay. Suppose in my this region, salt noise occurs. So this is zero. Okay. That at this location, suppose I am somewhere such that this value is sudden occurrence of paper noise. Otherwise, the values are 128. That means otherwise the region is gray, but sudden occurrence of that zero occurs, and my filter by moving filter scanning, by scanning I reach to the filter where this paper noise comes into center. So can you tell me in the output what will be the value if I'm applying max filter? If I apply max filter, what will be the value of the center pixel? 128. If I apply median filter, what will be the value? If I apply median filter, what will be the value? It will be also 128. It will also be 128, right? Okay, that's good. So what is the case like if such type of paper noise occurs, and if I apply median filter or max filter, this value will get replaced with 128, and that is what I needed. That was so sudden occurrence of this zero is now replaced with 128. So can I say that a sudden occurrence of zero is vanished, and hence paper noise is removed? When it is vanished now. Okay, sorry. So yes, paper noise is vanished. Okay. Now what if I'm applying mean filter? Mean filter. Where is 114? Where do you find 114, Rahul? All are 128. MIN. Sorry. Mean is not that mean. MIN. See, that is a good point, Rahul. You found average filter. Suppose I am using smoothing filter. Smoothing filter is used to remove the noise. Smoothing is finding average, right? So average will also make it 114, but it will not be. Of course, it is better than having zero, but still it is noisy. That is what I told you. That is what is happening here. Suppose this is salt and pepper noise, right? That so some noise is occurring here. If I'm using averaging mass, it is reducing the impact. Here also you can see. I'm not sure. I'm trusting Rahul's calculation, and I'm assuming that the calculation is correct. 114 will be the mean value. Suppose then it is better than zero, right? But what I was expecting, because it was not meant to be zero here, it was meant to be 128. So better result I'm going to obtain from median and max filter in case of paper noise, right? So I think this is justifying this point. Okay. Now, so it is now for mean filter. What it will be, Rahul, and others? What will be that mean filter value? It is going to be zero. Okay. So paper noise cannot be eliminated by mean. Paper noise cannot be eliminated by MIN mean filter, right? It can be reduced by average filter. It can be totally eliminated by max and what you can say. It can median filter, right? It can be eliminated by median and max. Better results you can get from that. Okay, suppose I am using mean filter and by scanning somewhere here, my window comes and still the values are like earlier. I am scanning now and these are the values, right? Whatever the values are here, suppose still it is, these values are, rest of the image is like this only, right? These are the rest of the pixel values. That means we have the image here, but by scanning this filter, I came here. What will be the value if I'm applying mean filter? Here it is 128, as expected it should be, and it is there. But if I'm applying mean filter, what will be the value? Value will be 0. Value will be 0. True. So can I say, actually, I wanted to eliminate this, but this pixel also became 0. This pixel will also become 0. All those pixels whose neighborhood 0 will appear, no, they are going to be 0 now because of mean filter. So can I say paper noise is enhanced using mean filter? Are you getting it? So that is what the point is. So okay, so can you, and the same thing will happen for salt noise by max filter. Okay, if it is a salt noise, that is 255 will suddenly occur, and I don't want that 255 sudden value, and that's why I should use either mean filter or median filter. Suppose both of them are occurring then, like this, both of them are there. So I cannot change my filter. Somewhere here it will be different filter, somewhere here it is a different filter. I want to scan using the same filter here, right? How would I come to know? Suppose it's both type of noise are occurring, and if I'm using mean, then the paper noise will get enhanced. Suppose I'm using max, then salt noise will get enhanced, right? So if both of them are there, which filter should I use? Yes, we should use median filter. We should use median filter. And that is what we have done here. Because in my original image, salt and pepper, both noises are there, median filter will give you better results. Okay, so salt noise occurs, you can use mean filter. Pepper noise occurs, you can use max filter or median filter in both cases, or both of them are occurring, then you should only use median filter. Otherwise, other type of noise will get enhanced. So that is all about order statistic filters. Now we are going for sharpening. Let us sharp our images. Smoothing completed, where the blurring occurs, right? More details on this, of course, Malay sir will take in the next session, right? Median filter and all. But right now, let us go for sharpening filters. What are the sharpening filters? They are, okay, in smoothing, can I say we were taking a summation, summation was giving us smoothing. So subtraction is going to give us, actually subtraction will give us the sharpening. What will be that subtraction? I will let you know. Okay. So so what it will do, it will sharpening will remove the blurring, that is it is opposite operation than the blurring. It will highlight the edges, right? That means what is edge? Edges are sharpened, it is going to sharp this edges, right? Edges are what how do you call the edge? Okay, so let us understand the word edge here. Okay, can I say this is edge? This is age, yes. So how do you feel that this is age? Because it was totally white area, sudden occurrence of different color, by that you decided it is age, right? Let me show you another thing. Can I say this is also age? Earlier it was not there, but sudden occurrence of different intensity is nothing but defined as age, right? So what it is going to enhance? It is going to enhance sudden occurrence of different intensity, that means age, right? So that is what we can see here, that it is going to highlight the sudden occurrence of different intensity. Sudden occurrence of different intensity is also noise. This is also sudden occurrence of different intensity. So it is going to enhance this as well. That means sharpening will enhance the noise. Okay. So before, if you want to apply, if you want to sharp your image, first you have to make sure that your image is noise free. If not, then you have to apply noise denoising techniques that you will study, you might have started studying, or you will study it in next by other session. In other session you are going to study that. Okay. So sharpening, we will need subtraction, and you know that as in the continuous domain, summation results into integration. Same way, in subtraction result into differentiation, right? So actually, I want to do differentiation or subtraction in the discrete domain. In continuous domain, I will call it as derivation or differentiation. Okay, so image sharpening is performed by first or second order derivative, right? That means in terms of differences. If it is a discrete domain, in our case, it is a discrete domain. Okay, so now what will be, so what are the characteristics of the differentiation? So what I want to do, I have my image, I want to apply differentiation. That means I want to apply differences, right? And differentiation here, if it is a continuous domain, right? So that edges are enhanced. Okay, we will see how the edges are enhancing. Okay, now, so I want to apply differentiation here. So what are, that is derivative here. So what are the properties? I should find out one operation in which those characteristics should be fulfilled, right? So that I will say, okay, it is a differentiation operation, right? What are those characteristics? So let us decide that. Suppose I want to have some operation x I am applying over here. That operation x should perform some characteristics. One of them characteristic is that if it encounters area constant values, if it encounters constant values, what it should be, what x operation is for first order differentiation. X is the operation for the first order differentiation. Now whenever x encounters constant region, then what should be the value? What should be the value of first order differentiation of a constant value? First order differentiation of a constant value is 0. That means that x operation, if it encounters a constant region like this, that all values are 128, if all the values, suppose here this is my image, right? In this all the values are 256, then what should be the value? What should be the value of first order differentiation of a constant value? Is it visible to you? Am I audible to you? Great. Okay, so what happened? Suppose it is a constant region. That means there is no age, and at that time, it should give me the value 0, and logically also it is correct, because in the constant region I don't have any age. That's why age, this should give me 0 response. Okay. Now second is, suppose it is ramp. What is ramp? Ramp is like this, gradual change. So what should be the first order differentiation of this type of line? If this type of line occurs, that gradual change in the intensity occurs, what should be the value of the first order differentiation? What will be the first order differentiation of such line? Some constant, yes. So this is known as ramp. This is known as ramp. Okay. So first order differentiation of a ramp should be this. We will understand what exactly it means, right? So if my values are constantly changing, suppose my values are gradually changing, right? They are linearly changing. Then that output should be a constant, right? So it should be non-zero along the ramps. It should be 0 in the flat areas. Flat areas means a constant region, right? Ramp is where intensities are gradually changing. Like suppose value is 128 here, and 127, 126, 125, so on. Okay. And what about this case? Okay, this is step. What is step? Before the value was different, currently the value is different. So sudden jump is a step. You are taking a step from the current value, right? So what is the first order differentiation of such step? Step is what? Current value was something else. Previous value was something else, and then sudden jump to the different value. So can you tell me what will be the first order differentiation of vertical line? Slope of vertical line will be infinite. It is going to be infinite, right? So what we are having is that it should be also non-zero. It should be actually very large, or it will be very large, we will see that also that it will be very large, and that large, but it will be non-zero at least, right? Non-zero at the start of step and ramp. Okay. So first order differentiation should fulfill these conditions so that it will give me ages. Of course, we have to verify this. Second order, so not only first order differentiation, but second order differentiation will also give me the ages, right? What should be the, so I will apply some operator X, which will satisfy some of the characteristics, so that I will say, okay, it is a second order differentiation. And what are those characteristics? Those characteristics are, suppose it encounters constant region. Second order differentiation of a constant region is once again 0, right? What is the second order differentiation of a line? Second order differentiation of a line. This line, gradually changing line, what it will be? Yes, it is going to be 0. So along the ramp also, here it was a constant, but it will be 0 along the ramp as well of the constant slope. Okay, and it will be non-zero at the start of step or sudden occurrence. When sudden changes are occur at that time, also it should be non-zero. Of course, this we will verify it properly. So what kind of operator it is? So that operator is nothing but this fx is defined as, for first order differentiation, it is defined as next intensity minus current intensity. This will give me the first order differentiation. It will satisfy all these conditions. For second order differentiation, it will be this equation. What is that? The next intensity plus previous intensity minus 2 times current intensity. Okay, so if I am applying this operation over my image, it will satisfy all this condition. That means it is going to all these three condition. That means it will give me first order differentiation in case of this, and in case second order differentiation in case of this. What is first order differentiation? Next minus current. What is second order? Next plus previous minus twice current. Okay, this is the same slide. Okay, let us do that. Let us verify that here. Suppose I have my image, in that values are occurring, right? So I'm taking this values, this pixel value is 1, 2, 5, 6, and that way I have 7, 2, 1, 0. In that way image is there, right? So I'm taking first row out of this. I'm just considering the first row of my image. It is 1D. I am considering first row. Suppose first row of my image is looking like this. Here it is 1, 2, 5, 6. In my case, it is this, just for understanding purpose. Okay. So suppose it is like this, then what will be the first order differentiation? So can you identify constant region of intensity? Suppose it is constant region here, then it is 1, 1, 1, 1. This will be constant region. So can you identify here constant area of intensity? This is constant area of intensity. Can you, if you can see, this is also constant area of intensity. This is also constant area of intensity. And that you can see from here as well. These are constant area, right? If you will see, the intensity is changing from 6, 5, 4, 3, 2, 1. It is ramp. You can see the ramp here. The intensity is changing, right? Here it is sudden occurrence of value 1 to 6. Can you see the step? Okay. So this type of intensity profiles are very common in my image. This is very normal one. Here also you can identify some steps. You can identify some ramp. Okay. So this is what my image strip is. Okay. Now let us apply first order differentiation. Start with this. Start at this pixel. This assume that this is padding. Assume that this is padding. My image starts from this. So what will be the first order differentiation? Next minus current. That is 0. Next minus current. 0. Next minus current. Okay. For this, it will be next minus current minus 1. Next minus current minus 1. For this, it will be next minus current 0. For this, it will be next minus current 0. Understood? Assume this is also padding. I will need for the border. Na? Okay. So this is first order differentiation. What about second order differentiation? For this, what it will be? 6 next plus previous minus current twice. Next plus previous, current should be subtracted twice. So 6 plus 6 minus 2 times 6, 0. 6 plus 6 minus 2 times 6, 0. For this, can you quickly tell me what it will be? Without looking here, the answers are there, but can you quickly try to understand it? What it will be? 1 plus 3 minus 1 plus 3 minus 2 times 2. What will be the value? It is 0. And let us think over this. Okay. For this, can you verify for this location, because it is important for this location I am asking. What is that? Can you understand what is the value here for this location? How we calculated it? Explain with the calculation here. What will be the value, so that I can understand that you are clear with this? Yes, it is 6 plus 1 minus 2 times 6 will be minus 5. Yes, exactly. In that way, I am going to get minus 5. Okay, that's good. Now let us verify whether it satisfied or satisfies all those previous conditions or not, right? Whether it satisfies or not. So in the constant region, what should be the first order differentiation? 0. Second order differentiation also 0. Constant region 0 0. Constant region 0 0. So first characteristics is satisfied in the both cases. Now ramp. This is ramp. If you can see, first order differentiation is non-zero. Second order differentiation is 0. Okay. And in the case of step, both are non-zero. But here I can and yes, if in the case of step, both are non-zero as expected, and it is having higher value, right? In the case of step, it is giving us the second order differentiation gives us a response at this point as well as this point, while first order differentiation gives the response at this point. But anyway, we are getting response somewhere here, right? So now if I will just give you this image, right? If I will give you just this image, right? What you will this is now, if I will, after modification, this will be your new image, right? So here you will come to know that this is what some sudden occurrence of intensity has occurred here, and here the age ramp started and here ramp ended. So that's at onset and offset of ramp, we are having non-zero value. That is what is pointed here. Onset and offset of ramp, we are having non-zero value at the second order differentiation. And for the step, both of them are having non-zero value, non-zero response, right? And for this, we are having non-zero response in the case of ramp for the first order differentiation. Now, exactly how that has what exactly this means, right? Suppose I'm having image some image like this. This is my image, right? Here it is white region or bright region, and it is my 3-bit image. Suppose it is my 3-bit image. That means my white is represented by 7. If I say this is my bright region, that means I will have in this, it is a white region. It is a white region. So can I say here, if I'm looking at this row, few of the readings will be constant bright. They are bright. That means they can be 7 or near to 7. They can be 6, right? So few of them are having value 6. So this region is having value 6. Now these values are this values. Okay, let me show you that image if it is available to me. Okay, I have that image. Just a second. Okay, so it is this image. If it is visible to you. If you can see this portion, I was talking about this line. I was talking about this line. Okay. Now, if you will see, this is a quite bright region, so values will be what 6 6 or whatever. Here the different values can be there, but the values will be what, it is a bright region, so it can have values. Some values will be 6 and all, and it is 3-bit image assume. Then what will happen, the values are gradually decreasing, that 6 5 4 3 2, you can see that from bright to dark region it is moving towards, right? And then the region is black here, right? So that means it is all the values are 0. Okay, so what we are having is, here the values are 6, right? And then we are having the values are 6 5 4 3 2 1, and then gradually it can be the near to 0, it can be 1 or 0, right? So in our case they are ones, so once we are having, then sudden occurrence of some intensity takes place, so that intensity is a 0. Okay, so this type of strip we were having, and what kind of response we were getting. So if you have seen that one, let me show you that too. What kind of response that we had. This is what okay, this is what the response we have obtained. Okay, for this, what is that? So here it will be 0 initially, for some bit it will be 0, right? After that it will be some non-zero value, so that means some value we are going to detect here. So here it will be 0, so I will say it is filled with. So what I will have here is that in my this region will be 0 somewhere, so this will be say 0, so it will be black region, right? This will be black region, some region is filled with 0, so this will be black region, right? Here it will be non-zero response, so in that way non-zero response I am going to get for all, and the non-zero response I am going to get for this all as well, right? So non-zero response for this region and this region. Okay, or if I am getting non-zero response for all, so I will have a thick edge here. If non-zero response for entire ramp, if I am getting, then this region will be thicker. Okay. For this again is a constant region. If you will see, 5 4 3 2 1 is completed. Then 1 1 1. This is this region I was talking about. Again, it will be black. So this region for entire case it will be black. So it will be black like this. We will not get response for this. It will be 0. I hope you can understand. It will be 0. Somewhere here again non-zero response I am going to get. So what will be the output? In output I will get like this will be filled with zeros. This will be filled with non-zero values if it is first order derivative, and this will be filled with again zeros if it is a constant region. Again it will be non-zero because of sudden occurrence of the intensity. Here if you will see, it is sudden occurrence of intensity, right? Sudden occurrence of intensity is there, like suddenly the value is 1 to 6, few values are 6, right? In that way you can consider. So again non-zero response you will get for this. So that is how ages are detected. Of course we will do this in practical, so it will be more clear to you, right? But what we conclude from this is that in the first order differentiation the edges are thicker. In the first order differentiation we are having thick edges compared to the second order differentiation because of this reason. Because they are, if the values of the intensities are gradually changing here in this region, then for all these ramp values it is going to give me non-zero. So entire region will be selected as age, while in first order differentiation, second order differentiation, I will get onset and I will get offset. So that is all about the second order differentiation basic equation. Okay, now we have one more case, that is how to use that in 2D. So we are using Laplacian for using it in 2D, right? So what it is that use 2D means what, that second order differentiation in x direction, second order differentiation in y direction, that is what is Laplacian, and addition of both. In x direction second order differentiation is what, next plus previous minus current twice. In the y order, it will be next plus previous current is subtracted twice, and if I will have addition of both, then it is going to give me this equation. Addition of this all will give me this 4 terms, and this term will be added together, so it will be minus 4 times. Okay, so this is what the Laplacian is. Okay, Laplacian is nothing but 2D second order differentiation for age detection. Okay, or rather I should say sharpening of the image. Okay, so if you will observe here, what we have obtained after applying the first order and second order differentiation, we are getting the ages. But what is sharpening? Sharpening is enhanced ages. That means after finding the ages, I have to add this age detected image to my original image. If you will observe here, suppose I am finding this is my image, and then if I am applying Laplacian here in the 2D, then I am going to get this image, right? I'm going to get this image, and that is just ages are detected from this. But I want sharper image. That means I have to add this value here, so ages are enhanced. So how to obtain? So suppose if I say that Laplacian, after applying Laplacian, this is my result, then that result I have to add in my original, then I will get my sharpened result. Okay, now how to do this using some filter. So if you will remember that if I am having the 2D window, if you remember, if this location is XY, so that location should be multiplied with -4. Center location should be multiplied with -4. This location, if you remember, this was y direction. That was this was f of x y plus 1. F of x y plus 1 is multiplied with 1. F of x y plus 1 is multiplied with 1. In that way, if I will go for all these locations are multiplied with 1, and we don't have f of x minus 1, y minus 1, if you can observe, right? We don't have the diagonal ones, and hence they are multiplied with 0. So if I'm using this filter, this is going to give me second order Laplacian. Instead of having all ones and 1 by 9, I should use this filter. Operation is same. Scan entire image using this filter and replace the center. Whatever the result comes, that result you are going to replace with replace at the center location. So that is what okay. Now what is sometimes what happens that that center pixel is having importance, right? So sometimes what happens that we don't want to have negative value to my center value, but I want to perform the subtraction anyway. So what we can do is we can alter this as well, because ultimately it is performing this alter the sign of the terms here. So then also it is a subtraction only. So that is also fine, that if you are using this filter, both of them are going to give us what exactly it is giving us: this pixel minus this pixel, this pixel minus this pixel, this pixel minus this pixel, and this pixel minus this pixel once again, right? That's why this pixel is subtracted 4 times. Okay, so I'm considering x direction and y direction. I'm detecting the edges in x and y direction, right? Suppose I want to detect edges in diagonal direction as well, then. So what I have to do? I take this pixel and subtract this twice. Take this pixel, subtract this twice. Current plus previous, current should next plus previous, current should be subtracted twice, right? So if I am doing so, then then this element should also be 1. This element should also be 1, right? Then what will be the result? The result and this pixel should be multiplied with 8, because again this is while calculating this area, we have subtracted it twice once again, and while we were computing for this diagonal, we subtracted it twice again. So totally 4 times we subtracted one, and we additionally subtracted 4 times, and hence the result should be this value should be -8. And if you don't want to negate it, then you can have this type of filter as well. So if you are using the diagonal edges as well, we are detecting the diagonal edges as well, definitely sharpening will be more, and this is the result, that if I am using diagonal edges, This will be the age detected one, and I'm using it somewhere here. So that will, if you will observe that, no, this is scaled version. This is the scaled version. What is that? Some constant value is added here so that you can see it properly. This is what Laplacian with the center 4 is applied. Then some constant values added so that the zero values are converted into grayscale. Okay, importance of this scaling you will understand in chapter 10 in detail. Right now you can skip this portion, but you can understand that just to avoid those zeros, just to see the result properly, display purpose, we have taken this. Otherwise, it is not having any other importance. So this is for the display purpose. For now, you can ignore, right? So this, from this we obtain this by using the mask with the center 4, and then we added this image here. We obtained this sharpened result, and this is obtained by by applying this mask over this. Age detected image is not shown here. Age detected image is not shown here. That age detected image is added here, and final result, if you will see, you can see these results are sharper, and the reason for being sharper is that we are considering the diagonal edges as well. Okay, so now what is the conclusion? Take your image, apply Laplacian. Laplacian can be any of these four, right? If you are applying this masks, that you are making your results negative because you are multiplying with the negative value at the center pixel, so your results are negative, right? And if you are using this, then results will be positive. Anyway, subtraction will take place. That will not make any difference there, right? But while you are using this, at that time you have to make sure, because your results are negative, when you want to add, actually you have to subtract your result from the original, right? So when you are using you are obtaining your Laplace image using any of these two A and B masks, your results of the age detected are negative because of negative sign. And now what I want, that age detected I want to add in my image. That means actually age detected image I want to subtract from my image, and that's why my C value should be -1 if I'm using mask A or B. And if I'm using this two mask, any of these two, then results will be positive. And if I want to add them, I will apply a normal operation of addition, and hence C value will be positive at that time. But compared to this A and C, the results of B and D will be sharper because they are considering the diagonals. And this is the conclusion of Laplacian filter. Okay, any doubt in case you can ask? Okay, fine. So we are concluding our lecture here.